Let me start with the new chapter algebraic expression including operation on algebraic expression. So now first we are going to study about the review. So constant, variable, and the word is term here. So constant, what is constant? A symbol which has a fixed value is said to be constant. Example here it is 8 to 23. So these all are symbols now and it is having a fixed value. If I am talking about minus 15, it has a fixed value, that is minus 15. Square root of 3, it has a fixed value, that is square root of 3. Okay, so this is what constant. So basically we will say for the numericals, for the numbers, we will say constant here. Now the next one is variables. A symbol which does not have any fixed value but may be assigned a value according to the requirement is called the variable, or we can say literal. It means here this is x, y, z, these are the examples. And here, as in the constant, it doesn't have any fixed value here. According to the question, the answers may be getting changed. So in the first question, if you found x equals to 2, in the next question you may find x equals to other number like a 10, 15, whatever. It is not going to remain same as it is. Like here 8, it will remain 8 value only. So okay, here the variables for the it doesn't have a fixed value. It may get changed. Okay, the next one is term here. What is term? Term is a number. It may be a number or we can say constant. So here it is what? It is term. It may be a variable. See, x is what? This is variable. We have studied already. So this is also what we will say. It is term or a combination of product or a quotient. See, 5 and x. 5 and x is what? It is having the relation in between multiplication 5. This is also term now. And here it is 18 by xy, 18 by xy. Here it is in the form of division. After division you will get the quotient. Okay, so variable or a combination of variable or a combination of this, also what we will say this is term here. Okay, now see here in the next algebraic expression, a single term or a combination of two or more terms connected by plus or a minus sign forms a algebraic expression. So what is algebraic expression? A single term. As you can see here, we have considered 7. 7 is also what? Single term. X is also what? Single term. 5x, 3x, y. This is also what? These all are actually single term only. So here let me take 5 is a single term and y is a single term. These both terms are connected by which sign? That is minus sign. So it become now what? Algebraic expression. Now we take this example. 6xy, this is one term and z is one term. Okay, so combination of these two terms are connected by plus sign. So it makes what now? Algebraic expression. That's why they are saying a single term or a combination of a two or more terms. So here if you are talking about, here it is more than 2. 1, 2, 3 terms are there and it is connected by plus or minus sign and it forms the algebraic expression here. Okay, here is a note. Various parts of an algebraic expression which are separated by the sign of a addition or subtraction are said to be terms of the expression, as we have discussed here. Now in this example, so you can just see here it is 5x cube, this is one term, 8xy, this is one term, and 7y square, which is again another term, is an algebraic expression consisting of 3 terms, 1, 2, 3 terms, and connected by minus and plus sign here. Now look at this expression. Again, this is an algebraic expression, and how many terms it is having? 1 term, 2 term, 3, 4. So it is having total 4 terms. Okay, only terms we will say we will not consider if it is a multiplication or division sign. Only we have to consider plus and minus sign here. As you can see here, 4xy square, which is having a relation like a multiplication. So but still we will consider as a one term only here. So in the second, it has been given that signs of a multiplication and division do not separate the terms. See here, 3x square into 8y. Still we will say this is a single term. What if it is having, instead of multiplication, if we are having plus, then we will say this is one term, this is one term. But still it is having a multiplication, this complete we will say one term. Similarly, here it is 3x square divided by 8y. Again we will consider this as a single term. Again in the place of division, if we have plus or minus sign, that time we will say this is two terms expression. But in case of multiplication division, we will not say it is a separate terms, we will say it is only one term. Okay, so an algebraic expression can either can be monomial, binomial, trinomial, and multinomial. Mono is nothing but only one term will be there, bio means two term, tri means 3, and multi means more than 3. 2 or more than 2 terms we will say multinomial. Okay, now look at this. Here it is only one term. As I told you, we cannot consider the division here. Okay, now here 8 and x, 2 terms. Look at this, 4x square and 6xy, this is a 2 term. Now look at this, 4x by y. This is one term minus 8y. These two terms are separated by minus. So hence this is one term, this is one term. So total two terms here. Now in the case of trinomial, now take this 7x is one term, 1 by x is another term, minus y square. These three terms are separated by plus minus. So hence we are having 1, 2, 3 terms here. Now look at this question like a multinomial. It may be two or more than two terms, we will say called multinomial. Okay. Hence we will say every binomial and trinomial we will say multinomial. Okay, etc. if it is more than trinomial also. Next is concept of polynomial. Here see algebraic expression whose each term can be expressed as ax raised to the power n. We had no here x square. Okay, now y square, whatever we had here, x square y. Like that ax square, where a is a constant, okay, and x is what? Variable, we have studied already, and this n, which is only whole number, okay, is called the polynomial. I'm again repeating, this must be whole number. We should not have any integer. That will comes to know in this example. Here it is 5x raised to the power 7 is a polynomial, as 5 is what? It's a constant, and x, what is that? It is a variable, and 7 is what? It's a whole number. Hence this is what? Polynomial. Now see here 5x raised to the power minus 7. It is not a polynomial. Why? Because 5 is a constant. Yes, x is a variable, but minus 7, which is not a whole number. Hence this is what now? It's not a polynomial. Now look at this 15 by x. Now when I'll shift x from the denominator to numerator, its power, it will get changed from plus to minus. So since I'm having 15x raised to the power minus 1, 15 which is constant, that's correct, x which is variable, that is correct, but this is the number, what it is there, no, this is not a whole number, this is, so hence this is not what? Polynomial. Now look at this 5x, this is a polynomial, but in this case I'll shift to the numerator, no, it will become minus 2. Again this is not what? It's not a polynomial. Okay, next one is degree of polynomial. Here when the polynomial contains only one variable, only one variable means in the complete expression there will be only one kind of variable will be there, like here it is x. Okay, so that we will say only one variable. The highest power of the variable is the degree of the polynomial. See in this expression, here we are having variable, here it is having variable, one variable this is, and which one is the having highest degree here? This is x square. So that is only what? It's a degree 2. Okay, similarly, okay, here the degree of polynomial. So here we are having one polynomial, and as you can see here it is only one variable, it is there, one kind of a variable, and in this, which one is the greatest having the power? That is x raised to the power 5. Hence this degree is what? 5. Now in this question, y raised to the power 8. So this is what? It's a degree, and here 8 minus 5x, nothing it is there, means there will be 1 for as a power. So hence in this, the degree of this polynomial, which is 1 here. Okay, in that B, when the polynomial contains two or more variables. In the first what we have studied, there was only one variable, here it is two or more variables. Look at this expression, we are having two kinds of a variable, x, y, and here it is also z, so more than two variables. Find the sum of the powers of the variables in each term, like each term. Here 3 plus 4 is, let me bring a pencil. It's okay, it has been written here only. See what they are saying, find the sum of the powers. Powers we need to add of the variables in each term we have to take. Like I am going to take the first term. Okay, so 7x cube y cube. So we have to only add the powers. 3 plus 4, I'll get a 7 here. Now the second term, which is minus 8x square y cube z raised to the power 4. Again we have to add only powers. 2 plus 3 plus 4, I'll get a 9. Similarly with the third term. So when we will add the powers now, we will get 8 here. Now 7, 9, 8. In this, which one is the greater number? The 9, which is the greater number. Hence for this polynomial, we can say degree which is 9 here. And a polynomial is said to be, if its degree it is 1, that we will say linear polynomial, and if it is having a degree 2, that we will say quadratic polynomial, and if it is the degree having a 3, that we will say cubic polynomial, and if the degree it is 0, that we will say constant polynomial. Okay, and 0 is said to be 0 polynomial here. Now the next one is product, factor, and coefficient. So in that first one is product. When two or more numbers are multiplied together, the result is said to be product. See, when two or more numbers, here numbers may be constant, or maybe only variables, or maybe the combination of constant and variables, that they have said both, are multiplied. Whatever the result we will get now, that we will say product. Here example, 3a, b and c. When we will multiply, no, the product we will get, that is 3abc. Similarly, 5x square y and z, when we will multiply, no, we will get 5x square yz as a product here. Okay. Factor. Each of the quantities, constant or variable, again both, which forms a product is said to be factor of the product. Now see here, 5 and x are said to be factors of the 5x. As in the last term what we have studied, product, no, when we will multiply 5 and x, we will get the product 5 and x. Now if I am talking about the factors of 5x, we have to make it a separate, like 5 and x are the factors of the 5x. Okay. Coefficient. Any factors of an algebraic quantity is called coefficient of the remaining quantity. Remaining quantity they are saying. See, for that example we will take, in the algebraic term or quantity 7xyz. 7 is the coefficient of, remaining quantity. What are there? X, y, z. And 7x is the coefficient. 7x if I taken, what left? Only yz left. 7xy. I have taken, and what left? Only z. So 7xy is the coefficient of z. Xz, let me take x and z. What left? 7y. So xz is the coefficient of 7y, and so on. Okay. Like and unlike terms. See, the terms having the same little coefficient are said to be like term. See here it is a term, right? 6xy square, and here it is another, I mean different algebraic expression. They have put the common sign here, no? Different. If you are comparing the first expression with the second term, is as you can see here, the variables also same and its power is also same. Okay, so y square, here it is a y square. So this we will say like term. And those having a different little coefficient are said to be unlike terms. Now look at this example, x and y. Here also x and y it is there, but here x is having a power 2 and here it is having a power 1, and y it is having a power 1 and here it is power having a 2. Since variables are same but powers are different, so we will say this is unlike terms here.